Hey class, it's Bill back, continuing our topic on generics. We started in and looked at the general idea behind them, and we wrote some super simple code that used a type parameter or generic when we were working on our little ID box concept. So that worked great. And now we're going to look at a little bit more depth about what are the shortcomings, what are the drawbacks, what can and can't you do, and a little bit more information about how it really works. So all of that will be hopefully useful in you understanding not only how to write them, but why certain things don't work when you go to try to write them in your code, right? So let's jump back down here to erasure. This is a critical topic. It's called erasure. Erasure means that when at runtime the generic is used, it's really converted into much simpler code than you might expect. The generic is not carried through all of the future of that object, that set of objects. It really turns the code into something really straightforward and simple. When you write something like this, when you create a new array list like that of string, what it really does under the hood, right, behind the scenes, is it creates a new array list of object data types. But then everywhere that is pertinent, everywhere that's important, like when you go to write code like this, right, where it just looks like you're just getting the thing out and it knows it's a string, the way that it knows that is because it's written that, right? It's literally turned everything into objects and casts. And the only thing that it does is do that at the time the thing is instantiated it. And then the important thing to know, that information is then gone. There is no way after the fact, after this initial code substitution is done, there is no way to know that the thing was ever generic or that there was a correspondence between this idea of a T and the string data type. That stuff is gone. It literally does that kind of simplistic substitution, right? Changes object creation to object data types, and then it makes sure that everything else is cast properly to make sure that strong typing is included. Okay, wow, so what does that mean exactly? Well, it's going to mean that certain things are not going to be possible because they would require this intimate knowledge and remembrance of the fact that this was a generic to begin with, and that's simply not present. So there are a number of limitations. First, you can't use with primitive types, right? That we've sort of already talked about. So because of the fact that these require objects, can't do primitive types. That's not a particular erasure thing. That's just a fact of generics. But here comes some interesting ones. You can't create new objects using a type reference. You can't create a dynamic type, right? You can use it as a static type, but you can't create a newly made T object, right? Most of these things, if you think about it, because of erasure, it can't figure out how that would work, right? Because, yeah, this cannot be represented, and most of these issues cannot be represented by objects and casts, right? So you can make a new static reference, static type for a binding, but you can't make a new dynamic type for the binding. Right? Now, we're going to find some ways around that. You can do the longer way around. You can make an object and you can do the cast if you want to do that, but you can't actually type this and it will keep you from compiling it. All right? Another thing is you can't use instance of because that would require this knowledge of the fact that this used to be a type. Right, that this was a T originally and now it has become integer. So instance of is out of the picture, right? Can't use instance of with this particular combination, right? What else? You can't create arrays, right? If you can't create the items, the objects, of course you can't create arrays of them either, right? Now, you will see that we can work around this in an interesting way. Again, we can make objects and we can do a cast, right? But you can't create new arrays with that as the type. Static, yes. Dynamic things and including arrays, no. Okay, so you can't do that either. Again, references are fine, and most of the time that's okay. Most of the time you don't need to make these new types of objects because usually the references are sufficient, right? Now, another thing that happens, and this is sort of a follow-on, what we sometimes do because we can't do this is we do this, right? We create a new array of objects, and then we cast it to an array of t's. Now that is something that you can do because, again, the cast works, right? This can be turned into a cast of string at that substitution time, and it works. The problem, though, is that Java has no way to know that that and all of its contents are really going to work in this environment, right? It would have to know that every object in that must be a string and that this thing itself could be cast as a string. So Java basically says, I can't do that. I give up, right? So if you look carefully, right, if we look really carefully using EXLENT, we're going to see that this thing is not considered to be kosher, right? This is an unchecked exception. And Java says, hey, this makes me very uncomfortable. I cannot really guarantee that this is going to work. Now, we know it's okay because we're just creating it new, right? It's brand new. It doesn't have anything in it. We can do that cast and we know everything's fine, but Java is uncomfortable. So one thing that we can do is before the method declaration, we can write this, at suppress warnings, quote, unchecked. And that says in this method, I know there's an unchecked exception, right? I know there's something that's unchecked, but I am saying that it's okay. So in the future, you don't have to check for it. All this does is suppress EXLENT from telling you about it. Right? Now, you have to be careful, right? Students, I know your brains. You're going to say, every time I see this error, I'm just going to go suppress it. No, no, no. 99% of the time, you need to go fix it, not suppress it, right? So don't do that automatically. Instead, when you know that it's absolutely required, like when we write array list, when we create the thing initially, we're going to have to do this, right? That's going to happen when we create array lists. So we know we're going to have this one. But other than that, we should have none of this, right? So you've got to be very careful when you suppress it. One other little note, this can be on the method, but that means if there's any other bad unchecked exceptions in there, it's not going to see those, which we don't really love. You can do this and put it on a single statement of code, which is kind of neat, but that line has to have a declaration. So you have to kind of write funny code to make sure there's a declaration, not just a binding on that line. Now, because it is so easy to do these things wrong, right? It's so easy. So when we, for our project, are going to write these generics from now on, it is very likely that we create problems that EXLENT can find. So we're going to say, hey, EXLENT, please find unchecked exceptions and raw types. Please find them both. And so when you go to, before you submit your project, in fact, don't do it the last minute, do it nearer the end so that you can go fix these. Remember to run this EXLENT that we've talked about in another video, and you want to make sure that you fix those issues, right? Most of them should be fixed. Very few of them should be suppressed. And you can ask in class, but the answer is, like in our array list code, it's one, right? You get exactly one of these and that's it. So be a little bit careful. Don't just suppress them. Do the right thing, right? Do the correct thing and take care of them right. Okay, so hopefully that kind of makes sense what some of those generics are. I think it'll make more sense once you make some of the errors and you go, why, oh why, right? Why won't it let me do this thing? And that's why, right? Because generics do have the limitations. Mostly it's because of the erasure issue. So hopefully that will make sense as you go, and we'll be using these generics a lot. We're writing array lists, we'll be writing linked lists and trees and all kinds of wonderful things, and they will all use generics, right? So we'll get very used to them. Now there are some interesting references here. If you want to pause the video, it would be a good time to do that now, and you can check out some of these things. There's a lot of good references on generics, but there are there are things that if you want to look deeper, they are there for you here. So that's the end of our talk about generics, type parameters, and again, very useful stuff, necessary stuff for us, and I hope that's a good introduction for you. Thanks for watching this video, and I hope you come back and watch another one soon. Thanks.